With AutoGrid on, it draws above the ground. Look, it's above. I wish it would come like this. The point is also above. If I turn off AutoGrid, where is it? So no one says, Dr. Abdul Rahman, AutoGrid. The AutoGrid is the checkbox at the top of the tools. I'll turn it off and draw another box. It won't be in the same place because it's not above. You're drawing based on the memorized area. There will be a difference. If I turn off AutoGrid, it won't draw above the black. We need to check the dimensions. Are they in the same place? You might not feel the difference. It's like a part of 1,000. Even zooming in, they aren't far apart. I keep zooming to see the difference and I'm not noticing. You understand? But if I turn off the AutoGrid, no one says Dr. Abdul Rahman AutoGrid. The AutoGrid is the checkbox at the top of the tools. I'll turn it off and draw another box, and it won't be drawn in the same place because it won't be exactly above. But there will be a difference. If I turn off the AutoGrid, it won't draw above the black now. We want to make sure about the dimensions. Are they in the same place? You might not feel the difference. It's like a part of 1,000. So no matter how much you zoom in, you might find them not too far apart. These are the boxes I prepared. You might not notice it much. This one is different from that one by a tiny bit, and that one is slightly lower. It's not noticeable, but now it's starting to show. This is the black one. If I disable AutoGrid, it won't draw above the black. The difference is minuscule, like 1,000th. Zooming in, I see no difference. These boxes are subtly different. One is slightly lower. This is on the ground, black is above. The last box is submerged, drawn above green. With AutoGrid on, it was above black. Some were above black with AutoGrid, others above green without. So these are the boxes I prepared. This one is different from that one slightly, and that one is slightly lower. Now it's showing that this one is a bit lower. This one is on the ground plane, and the green one is above it. This is the black one. Yes, this is the black one. But this box that was drawn last is submerged. It was drawn above the green. Isn't that what I did with the box behind? I had the AutoGrid on and drew it above the black. So some things were drawn above the black because I had the AutoGrid on, and some things were drawn automatically above the green because I turned off the AutoGrid. Okay, so these are issues you need to be aware of while working with the 3D Studio Max animation program, because these are key tools in the software. When you watch a video later to work on your own, keep this in mind. Now, regarding the modifier, I've gone back to everything, but I haven't gone back to the modifier yet. I'll go back to the modifier with you in a new way. I'll take a small example. Yes, this is the black one, but this is the box that was drawn last, diving under and above the green. This is not what I did with the box behind. I had the AutoGrid turned on and drew it above the black one. So there are things that were drawn above the black one because I turned on the AutoGrid, and there are things that were drawn automatically above the green one because I turned off the AutoGrid. All right? So these are issues you need to be aware of while working with the 3D Studio Max animation program, because these are key tools in the software. When you watch a video later to work on your own, keep this in mind. Now, regarding the modifier, I've gone back to everything, but I haven't gone back to the modifier yet. I'll go back to the modifier with you in a new way, meaning I'll take a small example. Creating an animated logo for the university, its name in animation. I make banners for it. I can come here from the tab and go to the text. Now, I have a place for this text. The text size is unchanged. I control its position, but how do I change its coordinates? As coordinates may be wrong, I'll set all to 0. 0 as before. 0, 0, centering it in the shape. The center is the lit point below. Oh. I have a place for this text. The text hasn't been enlarged or reduced. I just need to control its position. But how do I change its coordinates? Because its coordinates might not be correct. Here are the coordinates, and it's negative. I don't know how much, and negative how much. So I'll set everything to 0. 0 from below, just like we did yesterday and today. 0, 0, so it's in the center point of this shape, in the middle of the environment. But ironically, the center point is at the bottom of the shape. Where is the center point? Oh, it's that illuminated point down here, which is the center point. Oh. But ironically, interestingly enough, the center point is at the bottom of the shape. Where is the center point, you might wonder? Oh, it's that brightly illuminated point right over here, down here, which is the center point. Oh. Above it is exactly the center point, which means I can keep on looking for precisely where this center point actually lies. Where exactly is this elusive center point? Well, let me tell you. The actual and precise center point happens to be below this shape right here. When I hold onto my mobile device carefully and steadily in my hand, I find it easily enough, which clearly indicates that indeed this particular shape isn't positioned centrally as one might expect initially at first glance. Now then, wow, let me just move it back a little bit. Take this box and put it on top and make it at the center point. Set X, Y, Z to 0 and it will go down. So I keep it at 0 and I set Y to 0 and Z to 0. Box and text centers differ. The center point of the box is in its middle. It's in the base middle. Its center bottom, a bit lower. Text center is also center bottom. For a sphere, does its center differ? No, its center is central, as it's a sphere. That's why you feel it's centered from the top, but it's not in the middle. It's not in the middle. It's in the middle of the base. Look where it is in the middle of the shape's base, not in the center of the space. It's not center to object. No, it's center and bottom, meaning it's a bit lower. Now the text also has its center point in the center and its bottom, and this is also the center point here. Now if it's a sphere and this is the sphere, is it different? Is it also in the center below? Its center point is in its center because it's a sphere. This is a shape, so you'll find it right in the middle of the shape. The center point of the sphere is at its center. Nice. That's why it's drawn half above and half below. It's drawn like this, unlike the others, which are drawn on the base. The others are drawn on the base because their center point is below. In the center, wow. Now, if it's a sphere like this, its center is at the middle. Its center is in the middle. It's drawn half above, half below. Others are on the base, center, below. Center will be in the middle. Notice what's happening here. When you look at its center, you'll see it's the middle of the shape. The sphere's center point is at its center. That's why it's drawn half above and half below, unlike others drawn on the base, because their center point is below. If the center point of this shape is in its middle, and I change it to be center to object, its center point will be in the middle. If set to 0, 0, 0, it will be like the sphere, half above and half below. Notice what's happening here. This is the text and this is the box. When I change the center point to center to object like the sphere's center point is right in the middle. So if the center point of this shape is in its middle, if I change the center point to be center to object, its center point will be in the middle. This way, if I set it to 0, 0, 0, it will be like the sphere, half above and half below. Notice this area, this is the text and this is the box. When I centered it like the sphere, its center point was in the middle, but the box's center was below on one coordinate. So I centered it by changing the center point. All right, so the center point of this shape is not the same as the center point of the original boxes. This is the text. After changing the center point, I centered it to the sphere. Its center is in the middle. The box's center was in the middle on 2 coordinates, but below on the 3rd. So to center it, I moved the center point. Thus, this shape's center isn't the original box's center. If I rotate the sphere, it spins around its center, like Earth does. This box now rotates around its center. Previously, its center was at the bottom. As for this box, its center point is, yes, it was in the middle on 2 of the coordinates, but on the 3rd coordinate, it was below. So when I wanted to make it centered, I changed the location of the center point. All right, so the center point of this shape is not the same as the center point of the original boxes. No, this is an artificial point. Does that mean if I rotate this sphere around itself, it rotates around its center like the Earth rotates around its center? This box will currently rotate around its center. But previously, where was its center point? Its center point was at the bottom. Its center point was at the bottom. So we used to say it was a bit lower. So when I rotate it, it spins around its center point. You see, it spins around the point below, not around itself like before. As for the sphere, because its center point is in the middle, it spins around itself. So when you come to model the orbits of a solar system, like our colleagues in the Faculty of Science want to model the movement of planets around the sun and around themselves, the center point was at the bottom. When rotated, it spins around this point. The sphere spins around itself. Modeling solar system orbits is easy with our knowledge. You need a small skill to move spheres along paths to represent orbits. The center point of planets is crucial in their movement, rotating around the sun and themselves. The sphere spins around itself. Modeling solar system paths, like planets orbiting the sun and themselves, is straightforward. Move spheres along paths to represent orbits. This exercise can be done quickly and shown to students. Planets rotate around the sun and themselves. Move spheres along paths while spinning them to fulfill the experiment's purpose. That's great. This is a very easy exercise that you can do with what we've learned. By the way, you just need a small skill to move the spheres along the paths so that they represent the orbits of the planets. Therefore, you can easily do an exercise like this in just a couple of minutes and show it to the students. But you need to remember something very important. The center point of the planets has to be considered in their movement. You might be rotating around, for example, the sun while also rotating around themselves. So, how do you do something like that? You have to move the spheres along the paths while also spinning them around themselves to achieve this scientific purpose in this experiment. That's great. Excellent.